This is a lesson on how you calculate a standard deviation, and we're going to start with the standard deviation for the sample. And calculating a sample standard deviation is generally much more common than calculating a population standard deviation. So at the top, what we have is the formula for calculating the sample variance, and that's this S squared thing here is the symbol for the sample variance. And what we have here is a sum of the deviations between the individual scores, which is x, and the sample mean, which is x bar. And you calculate a deviation for each one of those scores that's in your sample, and then you square each of the deviations. That's what this squared sign is right there. Whoops. Right there. That's the squared sign. So you take an individual score, subtract the sample mean, and square that. And you do that for every single score that's in your sample. And then when you've got all of those individual deviations from the mean, then you sum them, then you add them all together. And when you have that sum of the squared deviations, the next step is to divide by n minus 1. And I'll try and explain the minus 1 thing in a different podcast. And to get from the variance to the standard deviation, the sample standard deviation is indicated with this small s. To go from the variance to the sample standard deviation, all you got to do is take this variance formula and square root it. So that's the formula. What you really do is you just calculate the variance, and once you get that number, then you just take the square root of that number and you get the standard deviation. Okay, so let's work through an example here. Say that I have a sample of three kids, and these are their ages. First one, x1, is 3 years old. Second one, x2, is 4 years old. And the third one, x3, is 5 years old. And here, I've calculated the mean for this group. 3 plus 4 plus 5 is 12. 12 divided by 3 is 4. So the sample mean is 4. Then what you do is you take each individual score, in this case, oops. So you got each individual score, and that's these over here. And from each individual score in the distribution, you subtract the mean, and then you square that difference. So 3 minus 4 is negative 1. Negative 1 squared is 1. 4 minus 4 is 0. 0 squared is 0. And 5 minus 4 is 1. 1 squared is 1. And then this is the sum. You add up all of the square deviations, and you end up with 2. So 2 is the sum of the squared deviations. Alright, so everything above the red line is the individual scores of the distribution of the sample, and then here again is the mean, and this is the sum of the squared deviations. So notice that you have to square each deviation, because if you don't, you'll end up with some negative numbers and some positive numbers, and when you add them all up, they'll add up to 0. So if you square each of the deviation scores, then you'll end up with a positive number, and you can calculate a standard deviation. When you do square them, and you calculate the variance, you take the sum of the squared deviations, which we found was 2. We divide by n minus 1. N in this case, there's 3 scores in the sample, so n is 3. And 3 minus 1 is 2. And 2 divided by 2 ends up being 1. So that is our variance. And then all we have to do is divide our variance, or not divide, but take the square root of our variance to get our standard deviation, and the square root of 1 is 1, so that's our standard deviation. Very simple. Okay, so that was how you calculate the standard deviation of a sample. Calculating the standard deviation of a population is really simple, just a couple of little adjustments. So first thing, the symbol is different. So it's one of these. Well, that's not a very good one. It's like that. And the other difference is that instead of dividing by n minus 1, you divide by n, so all of the scores in the population. In this case, there's 3. And so what you get for your variance, is 2/3, which is 0.67. And that's what you plug in to your square root, and that gives you a value of 0.82. So instead of a standard deviation of 1, which is what we got with the sample, we get a standard deviation of 0.82 if this were a population. And the bigger the sample, the smaller the difference is going to be between the sample standard deviation and the population standard deviation, because n minus 1 is going to be a smaller difference if you got a bigger sample. So that is how you calculate a standard deviation for a sample and for a population.